In today's short webinar, we're going to show how to do topographic adjustments using GPR Slice software. And we'll go right into what we're trying to achieve. Here's a site where we've adjusted for topography. This particular site that we're going to be studying today is the Site Tobaro National Burial Mounds in Miyazaki Prefecture, Japan, where we ran a workshop in 2022, right after COVID. And we'll be studying the small burial mound here. The data was collected with a ProSec GS8000 and using the GPS free path. Okay, so what we're going to try to achieve is to show you how to do topographic adjustments to the data and present all the radargrams as well in topography. Okay, let's get started doing the basic processing. We're going to create a new project, and let's just call this Topo Demo 1, and we've chosen our equipment type, which is ProSec. We create a new survey, and then we transfer the data into the project. We have it on the desktop here, and we just get to the top of the folder and import all the data. And we can see where the data has been imported. It all appears in the raw folder of the project. Our next step is to create an information file, and we choose a GPS for this particular data. And we have a quick import button here. This has high frequency and low frequency data that is collected at step frequency. And for this manufacturer, we click on the CSV file, we open it, and it automatically creates information files. And it has a high frequency and a low frequency data, and we're just going to process the high frequency data here. To get the navigation, we have a button here called ProSec Nav Area. This is not total station, it's GPS. And all the listings for the project, GPS listings, appear here in the fourth column of the information file. This is just a single profile that was collected on the site, but you can have multiple profiles. And let's go ahead and take a look at what the GPS track shows. And here's the GPS track shows. There's where it started, and here's where it ended. You can collect data like this. This was just a quick demo for showing the equipment at the site, but we normally would want to collect data much higher density on a burial mound if we were really completely studying it. Let's move on to the next step, which would be to convert the data to GPR Slice format. And here's what the data looks like. We will just, for this particular manufacturer, there's no low frequency drift in the data or wobble, so we just say batch gain. And we're converting the data here. We're not going to be running in multi-thread today for most of the processes because it's just a single profile. Multi-thread, if we had more than one profile, then we would use multi-thread processing to speed things up. Our next step is to apply the navigation, and this just tags all the GPS information on top of the scans where they were recorded. Our next step is to do radargram editing, and lower the threshold a little bit. There's three kinds of thresholds that we can use to trigger where time zero is, or the start of the ground wave. One is we look at just a threshold value, and we trigger right there. The other one is past that threshold, we find the first peak plus or minus response would be method 2, or we can find the first zero crossing of the signal past the threshold. We're going to use just method number 1 and get this all onto the screen here. We found that the 6th sample was where time zero is located for this particular profile. And here it's showing us that we've cut off all the information above the ground wave. And then we're going to update to the new information file called info-hf-edit. Okay, our next step will be to go to the filter menu. We put on the edit folder and we can look at spectra plus gain. We're going to apply a gain curve to the data. So here's a gain curve that we can apply to the data if we would like. And you can, as you can see, because this is step frequency equipment, that there's really no low frequency noise or high frequency noise. The equipment's already been decided on where the frequency response is going to be recorded. And the other thing that's to note is that we see pretty much a fairly flat spectrum. There are peaks and troughs, but more or less the frequencies are more or less uniform in amplitude, which is very good. You can scroll through this to see if that gain curve is going to look reasonable for the rest of the data, and it looks pretty reasonable. Okay, so let's go ahead and run the bandpass. So it's doing bandpass filtering and adding gain. Again, with the ProSec equipment, the data's already been bandpassed. We can bandpass it more if we wanted to, but there's really no need. Here's the data, and again, this is quite a long line. We have 185 meters here, and this is data that's actually taken off the burial mound, and this is when we get on top of the burial mound, but we can see that later when we actually process the data. Now, this banding over here is not really noise. There's a lot of layers, volcanic layers at the site, but we could take those out or process the data if we wanted to, just to show you. If I wanted to do a background filter, let's say I just did a background filter, and this background filter is, I'm sorry, we had to put on the bandpass folder because we just did bandpass. This background filter looks at just the average scan taken across the whole site and subtracting it. Now, if you still felt that this was noise, for instance, what you could do is you could actually shut off auto set and say, let's say I want to make the background filter just have a window of maybe 200 scans, for instance. And then, so it's doing a moving average over 200 scans and subtracting it. And you'll see that this could take out those bands if you wanted to. You have to decide what you need to do for your particular project, and if the data is noise, then you can remove it. You have many options. I'm actually not going to use the background filter data. I'm going to use the original data without background filter. When you do a time slice of data in the background, if you have background noises which are constant across your line, when you do a time slice, you don't see that because you're just looking at differences. So time slicing actually removes background noise to begin with. So you shouldn't really filter your data any more than you need to. And okay, after we did the bandpass filter, we want to look at the search for. So now we want to make this a lot longer. I'm going to make this 20,000 pixels and make 20,000 pixels and make this maybe 600 pixels in that. Resize, redraw. You can go up to 64,000 pixels to display anything here. And I think it might be useful to, at least for migration, to choose a color table, a black and white color table. So I'm going to resize, redraw this again. Okay, and then we have some hyperbolas here. Well, one thing about this area, we noticed that it really does have a very low velocity, these volcanic soils. And then you want to choose an aperture size. I'm not going to make it too large because I don't want the migration to take so long. But let's say I wanted to go with that. I'm going to go a little bit higher on velocity. We have 7.2 centimeters per nanosecond. Then we're going to run test migration. Now the test migration is actually running the filter, and it'll actually write whatever radargram you have here into the migrate folder. So after this process, after we test it, we actually don't have to rerun it again in the main menu, only if we had other radargrams in the site. Actually, we do see a little bit of noise, sort of bandy noise in there, which could be removed if we did a background filter. But at the same time, we're going to time slice the data, and that noise won't appear in our time slices. And if you do note that on GPR Slice, when you take data for GPS, that it shows three labeling. It has the eastings, northing, and the total range along the line of that GPS point. Again, we're only using one radargram, so there's nothing we could do here in multi-thread. Multi-thread works on multiple radargrams. And this particular computer has 16 logical cores, so we can actually process 16 radargrams or do 16 grid processes at a time. Okay, that looks like a reasonable migration. We collapsed some of these hyperbolas. Okay. Our next step is go to the migrate folder and let's just do a Hilbert transform on the data. Okay, there's our Hilbert transform. From here then, we want to slice the data. So we're going to put on the Hilbert folder, let's say we want to do 50 slices, bins per mark, we want one. This particular manufacturer has GPS scans, GPS information on each scan, so there's really no binning process that needs to be done. The bins are going to be almost on every scan. We just want to hit help thick with 50% overlap, and we have our identifier here called H, so we're going to go ahead and run this now. And this will create 50 ASCII files of time slice information, which will then go to our gridding menu and grid those data up. So now writing the time slice data. Okay, our next step is to do gridding. We're going to come in here and we'll just put this on draft quality. And I'm going to start out with a search radius that's kind of narrow. And you can see what it does. It's using the 0.5 meter search radius on the data on the grid. And we use a 10 centimeter pixels. And so you're seeing data like this. I don't think we'd want to create data like this. Kind of looks like DNA readings in a way. And you notice that we're not actually interpolating past the lines, and it's not including data on nearby transects of the GPS profile. Now what you could do is, if you wanted to still see the tracks, but you want to interpolate further, so we could actually set the search radius out. Let's just make it, for instance, 2. But I'm going to leave the blanking radius the same at 0.5 meter. And now we're searching out further, and we're interpolating across the line. So you can actually see features that are maybe more coherent by searching out, but still preserving what the track looks like. Now, I'm not going to create data like this. I want to make everything solid. So basically, what I'm going to do is I'm going to make it, I'm going to bring the blanking radius up a little bit higher, maybe to 1.5. And then we'll show how this looks. Okay, now the other thing is you've seen that it looks like the edges are getting cut off. It's just that we're interpolating past the GPS track. So what we could do is we can add some length onto this. For instance, I could say, let's add 2 meters on to the sides here. And let's make the search radius a little bit smaller. And now it's added 2 meters onto the grid. You can actually do this manually as well. And that maybe looks a little bit more reasonable. Okay, at this point, what we could do is we could turn on multi-thread, and I have 16 logical cores here, and for those that don't know how to do it, you just go to your Windows to look at your processor. Okay, let's do this in multi-thread processing. So it's now going to be processing 16 grids at a time. Okay, I always like to at least do a 3x3 low-pass filter on the grids, and it's going to append the letter L onto all the data, and that's finished. Now we can look at all the grids here in the T-Slice menu, and I'm going to click on the LH data, and let's make this like 150% of the screen. And here we can see all the profiles. You can see things look a little bit red. Is the reason is we haven't set all the histograms yet. So what we need to do is we need to set the histogram settings, and we want to look out 3 standard deviations from the mean. So if you just hit auto gain all, it's going to colorize each of these maps independently. Let's redraw it. And what we could do is I have numbers on the color bar here, and they're 32-bit numbers. We're going to have to do just a little bit of custom displays here. I'm going to make each map 300 meters or 300 pixels, and I'm going to shift by 600 pixels in X and Y. So this will allow us to look across the data here and see the numbers on the color bar. And you know, sometimes these numbers in another webinar we'll talk about relative normalization versus absolute. So for right now, I can come over here if I want to shut off those numbers just to make things look a little bit nicer. I can shut off those numbers, and we have the data looking like this. Okay, once we have all our time slices and we like the colorization, then I'm just going to interpolate between the maps. So we're actually, really, you can say we're actually interpolating between colors at this point when we're working on relative normalization. And from here, we actually have our flat data. Okay, now how do we get this into topography? So we go over to the static menu now, and we go, first we want to extract the GPS data. And just to show you where that data is located, for each profile that we have here, and we only have one, there's a GPS file, and it's loading. This has got 16,000 lines of data, so it takes a little bit of time to fill up the table here. And here it is. We have eastings, northings, elevation. We record time in one of the columns, the 4th column, just in case you want to do latency corrections. Then we have the scan number, GPS quality, number of satellites, and the HDOP. And at some point we'll talk about vector in another webinar, where the vector of each scan can also be included. Okay, so when we're going to need this information, the first 3 columns, eastings, northing, and elevation. And when we go to the static menu and we hit this button, it's actually going to extract that information for us, and it even tells us what the min and max of the data are. And this has almost 2 meters of elevation change on that particular burial mound. And our next thing would be to compile this to a format where we're going to grid it. And then we have the grid topo1.data. It goes back into the same menu here. I'm going to shut off multi-thread. We want to create the grid map identical to the time slices. And what we really want to do is we want to make sure that it's completely inclusive of all the data. We don't have any edges there. So I'm just going to add a little bit to the blanking or the search radius. And now we're going to make the topography grid. And there's the topography. And then once we have that, we can go right into the static menu, and the data will get warped into the topography. Let's get a Google Earth map first. We want to go to the BMP image, grid 2D. I'm going to put this on a zoom level of 19, and we just hit get Google image, and then we want to hit the button called get corners. And then it's finished. And here's our data on top of the burial mound over there. And you can balance it this way if you want. We can also look at it in X cuts along the data. And we can also look at it at Y cuts as well. You can actually even store that. We can put down a ZT, and then you're actually seeing some cuts that look like that if you want. Let's go down a little bit of ways, and then we can even put on an ISO surface. Let's stop right there. Let's store that, and let's put on an ISO surface that's a little bit higher. Let's go to 85. And what that is the 85th strongest amplitude in the volume. We can also get on a radargram, so we can put on, let's say we want to get the, let's put on the migrate folder. And we can actually store that if we want, and hopefully we can get everything to the screen. It takes a little bit of a while. This has got 16,000 scans of data. And there's showing all the radargram data that we collected on the site Tobaro burial mound. This site here in Miyazaki Prefecture, the National Burial Mound Park. These burial mounds date from the 4th to the 7th century, and there are several mounds on the site that actually have imperial family tombs that we studied as well. And these minor mounds are administered by the prefecture, and we get access to those, and we've been studying these since 1993 with a colleague of mine, Noriaki Higashi, who's now the assistant director of the museum. Anyway, that's basically how to get data into topography. And just a note, we have over here, we extracted the GPS topography, but you can also import topography, which would be just X, Y, Z, and you can do the same operations for that. Anyway, that's real basic procedures to get your volumes and your data into topography in GPR Slice software.
Excellent. Thank you very much, Dean. We have a little bit of time now to see if we have any more questions that we can address from the great amount of people that connected today. So I don't know, Dean, Alex, if you guys want to address some of the things that our participants are asking.
Oh well. Go ahead.
Yeah, first of all, thanks everyone for attending. It's overwhelming to see so many participants, and you keep me very busy because I'm here still answering questions that I see on the chat and in the open Q&A. So yeah, we can take some more. There was something here interesting, Dean. Somebody's asking, Todd. Sorry, the last name, maybe I don't try to pronounce it, but is how can you tell from this data how many burials there are and where they are specifically located?
Well, this particular data was not high density data. It was just for a demo to do this demonstration very quickly. When we normally go to this particular site, we take data at 25 centimeters, sometimes 50 centimeters on the ground. And these cemeteries are not like cemeteries in the Western world. These are one burial mounds, and there's usually only one or two burials on the site. They're usually chambers beneath the site. Maybe I can show a quick, if I can share my screen. And I think people have already seen this on our website before. Here. Oh, I hit the sheet. Are everyone seeing my screen? You're seeing my screen?
Yeah, I think so.
Oh, okay. Okay, so these kind of burials are, this is the logo of the software. These are little burial mounds. They're only, 50 to 100 feet in circular. And this is how they were built, building a moat. And then there's one person often buried below it. So there's just one big chamber. And we're usually looking for a big reflection from a subsurface chamber at these sites. And for those that don't know what the logo of GPR Slice is,
this round circle in the logo is a burial beneath this moat. So, yeah, this is not like cemeteries in the United States where we have everything in rows, which we image as well. But, any other questions? I guess I got to go back to the chat to take a look. Maybe
there are many questions. I'm typing here. One of them I was typing here is that if you can use GPR Slice for applications indoors, of course you can drag and I'm here typing, and we might do at some point also a webinar on concrete imaging with GPR Slice. We have many examples. We have also some videos on the YouTube playlist. So yeah, of course you can. Maybe we can have a look here if there are many questions, some questions that are interesting to all the attendees.
I know there was one person that asked about the system. Let the person, if you had a question about the system I'm using, this is an older computer. I think it's 7 years old, but it already had 16 logical.
Okay, can you hear maybe the specs?
Yeah, take a screenshot if you need to. But I wouldn't say that's the minimum computer. You could even have a worse computer. So I do training with people every now and then, and it takes longer to process data, but they're able to work on very weak computers with the software. It's 32-bit software, so it doesn't require a lot of memory.
Okay, a lot of questions about applications and depths. Is it possible to arrange a demo for using it and know it deeply? Yes, we offer 30-day free trial. You just need to go to the website. Maybe can you go to the website quickly, Dean?
Yeah.
GPR survey.
Okay. And they would want to go to subscribers only, right? So that come in. So you'd come here. Is that correct?
Yes.
Yeah.
Yeah, in subscribers only. Yeah. Then you download this GPR Slice installer, and then while you are doing the installation of the software, you just choose an option called Evaluate, and will give you access for 30 days. So that's as simple as that. Then Adam has a good question, and maybe Dean, you can show. Maybe you have it on the same presentation about the level plane time slices, because we were showing only warp, right?
Okay. Yeah.
Maybe you on the presentation.
Let's show real time. So the reason
real time,
the reason we broadcast this is because the internet, who knows what could happen. So level plane slices. So we do have an option where you can just come in here. So right now these are topographic slices. There's something here called ZT, or ZL, I mean. So here's the level plane slices where it's actually cutting across that, and it's doing it real time. So you can actually store, so now we're at the bottom of the site. You can even go back up. So you can save a few sites. And so that's level plane. There's also options in the software to, it's blocking it, where we can actually make binary radiograms. So we actually make new radiograms that are binary, and then we can actually slice that data as well. That's also available. So, but we nowadays we're trying to do everything real time. So we have all that capability in the warping menu. ZL would be it.
Could you please also, there is a question about the formats, maybe just showing the list of manufacturers and formats that GPR Slice.
Yeah.
Somebody just joined late, Marco Tuccio. You can see.
Yeah. Go ahead. So we
use ProsecSegWay for this one because we were loading data from the GS8000, Prosec GS8000. So that was the when Dean started this processing, he was choosing the ProsecSegWay. But as you can see, there are many formats here. Somebody else was asking about the GS9000 data. You can see also we can we can have GS 9000 data on GPR Slice. And I mean, here is not the. I don't know if you have some here of the ones that we are going to present in China. I mean, it's
It'd be dangerous.
if you just have it, no, just if you have it somewhere. But yes, the answer to that question is yes, you can add it.
I don't know if this is a project that's ready to show. So, okay, it doesn't have it there. I don't know. We're interfaced with the GS 9000. All multi-channel systems we're interfaced with. So. Just see if there's anything.
I don't know if you have the Brookhaven data with the reroutes.
Yeah, let me just see what's here. I have this one as a grid block, so I'm not sure what this one is. This one's a grid block, requires the grid block. Oh, so yeah, this isn't very interesting data, but it's the GS 9000 on a city street somewhere. Not even sure where it is. So we have much better looking data. Okay. Oh, this one that shows the bridge deck. Oh, is that a bridge deck? You know this. This is one of the sites that I think. So this is the GS 9000, and I think it's the 2.5 centimeter data. Is that right, Alex? It's got to be, because the
yes,
rebar is shown in all different directions. Yeah. Okay. Yeah. Oh wow, that's nice actually. You got lucky, right? Because I don't know I got so many projects. I don't know which folders to go to. Yeah. For somebody that's been in the field a long time, to have no one ever imagined getting 2.5 centimeters on the ground. It's just amazing.
One question that was specific about what we did today on Site Tobaru is from Jose Vicente. He's asking the bins per mark you use with that GS 8000 on that data set.
I'm sorry, what was the question?
Bins per mark. Bins
per mark. Oh, yeah. For ProSec data, you always use 1, because the bins per mark was pretty much. You would always use 1, and the reason is it's even over bin. ProSec records GPS on each scan. They may not record GPS real time on each scan, but they manufacture GPS on each scan in their log files. So as far as we know in GPR Slice, the data is, every scan is tagged. So you can't bin it any further inside the data. Normally, particular manufacturers would have a GPS every 10 or 15 or some random number of scans. And then we would go and say, well, we only want to make 2 or 3 or 4 bins between those markers. But there are more advanced options. And I was actually working with one of our users in Kentucky, where you can actually, boy, this might be take too long to open up. I'm not sure if it'll open up here. Just going to go to the single channel, so it doesn't take too long. There's options to what we call even resample the data in range. So sometimes people that collect in time, they don't have equal scan density on the ground. And there's options to go back and resample the tags on that data based on range. So I have a few users that use this option here quite a lot. And they may have GPS on every scan, but they resample it in distance. And then they maybe make bins every 10 or 25 centimeters or whatever they need. So there are a lot of options to adjust it, but bin per mark for ProSec should just be 1. It shouldn't be 4.
And there are more questions about videos. I think I posted already on the chat a link to the playlist. And we have several short videos that explain from introduction actually to some of the advanced features, shorter videos, maybe 3 to 5 minutes. Then about the user manual, Alvaro, I'll follow up later with that question with you. How does gain settings impact level slicing from John Steinberg? Maybe you want to get that one?
Is that John Steinberg from?
Yes.
Oh, hey, John. Well, you know something, I could spend a half hour talking about gain curves. And
we have 25 minutes.
okay, well, and let me just go to a project, not this one. This is a multi-channel. Let me see if I can go to that Zane Ringer project. If not, I just go to Treasure. Treasure is okay to go to? Let me just do that. Sorry, Alex. I'm just going to do this here. So let's see if, oh, these are over there. Let's see if we're ready to show something here. Yeah. Okay, this is good enough. Let me just put this up at 4. Sorry, I wasn't prepared. So, you know, we work in relative normalization or absolute normalization. So what absolute normalization is when you put a gain curve on your data, you're stuck with whatever gaining you apply to your radograms below that. So certainly, if you don't put in a good gain curve and you create a 3D volume on absolute, you're not going to get you may not get a good imagery. So this is showing the data on absolute, where the ground wave was very strong, and then down below we didn't have a good gain curve. So what we do is we show the data on relative, and we let each map be independently colorized from the rest. And are we justified to do that? I think so, yes, because imagine if you have one area where you have a reflection at subsurface depth, and another area you don't have that same layer. Well, the signal that goes below that next layer has already been reduced. And you may have a similar layer that's down below, but it may be weaker over here than it might be over here. And so normally we want to use everything in the relative normalization. And what we do is for each map independently, we colorize each map independent, and then we interpolate that. I think this is a unique feature that isn't done in other software. And we came from the world of archaeology, and we wanted to be able to create a contrast at each level, because you may not have a strong signal in certain areas, and your map might just look like it's all blue. So yeah, you have a choice to do that. If you created a volume like this, it may look like something similar to what your data is. You can come in here and even adjust one map if you wanted to. I'm not sure what this is going to do. And you can actually bring things up. So in the gain curve, you can spend a lot of time. Let me just open up that gain curve menu if I have everything on. I don't know if I have the right, could be, let's see here, go to the static filter menu. Hopefully it's in there. Okay, so here's how the data looks. I can take this data and convert this data without any gain, and we'd get almost the same time slices if we applied gain to it. Okay, now this gain curve here is your choice, but at the same time it's arbitrary what you're going to add there. So if you want your volume to look exactly like your 3D volume to look exactly like the time slices, then use a good gain curve. And then when you create your time slices, leave this on absolute and not relative. Okay? I hope that answered the question. I was a little bit lengthy. Sorry about that.
Sorry, I was muted because I'm typing all the time. There are many questions here. There was one about, I don't know if you have it in, just to show, I was recommending, somebody was asking about collecting different grids in different seasons and then having mosaic noises. Didn't call it mosaic noises, but yeah, we have all the explanations on the manual from page 300.
I just pointed out, we have, what you do is, I don't know if this is a good example. This is a small site. What you do is, if you have blocks of data, I'll just show this. You come in here and you say, this is the start of my first block. This is the start of my second block. This is the start of my third block. And then you would save that. And the way it looks then is, go to the good plot. So I have these different blocks of data. And they don't have to be rectangular. If you're working in GPS, they could be blocks of GPS data. They could go in any direction you want. And then if you have mosaic noises, there's different ways to try to correct it. There's a quick way, which doesn't always work so good, but it's called XYZ zero mean grid. And what it'll do is it'll compute the mean of each of those blocks and subtract it from the time slices. And you can get rid of those mean amplitudes by that. There's also something called zero mean line. That's a little more severe filter. It's like a background filter in the grid mode. The one that works the best, but it's the most time consuming if you have an important data set, is to actually come into here. You would make 3 different sets of time slices. And what you would do is you would come over here. I'm not set up to do it, but you would type in the A, B, and C data. And so you'd have A, B, and C1. You would draw the first 3 data, and then you can adjust the transform independently. You would adjust the transform. I don't actually have that data here, so I would just, you would adjust the transform independently of each one of those to get the images to match. And then you append it right there. So it's a lot more time consuming, but you have much better flexibility to try to get a good connection between the data. But your first step is to do zero mean grid in the slice menu. That's your first weapon right here.
Okay, I was just answering. William was asking about the, if in the topo correction we also have a way to correct for the angle of the GPR. So I guess he meant the tilt. So we have tilt correction also.
Okay, let me just go to a quick example. I mean, we should make these separate webinars because they're more involved.
Yes.
I mean, let me just see if I have an example here. So here's the data. So I want to go to OpenG topo volume work. Okay, let me just make this larger. And gosh, I gotta bring this down here. It's putting a little bit more vertical exaggeration. So here's some topography. And here's the data corrected for the tilt. It's a 3D radargram. When you work in vector space, radargrams are 3D. So we have all those capabilities in the software, even before the software was acquired by Screening Eagle. I've had vector topography now for 9 years, maybe, in the software. Quite a long time. So the way you handle all this stuff is that it's pretty simple, actually. It's not that difficult. If you came over to here, where's the, well, I put on the original information file before it got vectorized. So here's your typical data that is just, the radargrams are just flat in 2D space, right? And to create that, get that into vector space, it's pretty simple. First of all, you take your information file and you convert it to a vector information file. And then it writes the info edit v file. And then there's just one other button to touch. It's called static topography. And it's called generate topo vector normals. What this does is it reads the surface of the topography and gets the vector for you and puts it into the information file or the navigation file. Okay, and I'll show you what it's actually done. We'll show you where the vector is actually stored. I can click on any of these radargrams. It should be in one of these. So there's the actual vector of each scan that it stores. Okay, and then when we want to display that, and this assumes that the antenna is normal to the surface. But in the past, we've had people where we've actually imported accelerometer data. So we actually know how things are tilting in real time. You can do that as well. But we go over to here and we go back and our radargram should be in vector space. So there they are in vector space. Okay. And you can see that it's following topography. I think you can actually put on a net of the topography. I haven't done it in a while. Net. I could store that, put on a little bit more vertical exaggeration. Okay, it makes the net a little bit, okay. And then put on your R, and they're bound. Okay, so There's your thing bouncing through the topography. You can also adjust the lighting. You can go to the draw menu and you can show us the way that lighting is hitting the radiogram. So you can play with the light intensity if you don't like it, if it's a little bit too dark. Sometimes it gets too dark when you're in there. You want to come over to here. And then you, oh, sorry. Yeah, you want to go over to here, I think it is. Yeah, and then you have these things where you can adjust the light azimuth real time if you're trying to make a video or something. Okay. Any other questions?
No more questions. Maybe one that we didn't answer, I think, and this is more for Angel, is that if we are going to make this video available afterwards.
Yeah, absolutely. Actually, I think Lacey shared it before. It's going to be available on YouTube and on our website. Yeah. Also to the participants, they will probably receive a link right after the session on the via email, and that there will be probably also the on-demand webinar already accessible for everyone.
Okay, there is one hand raised here, but I don't know what that means.
So you can allow the person to.
Now it's maybe it was by mistake because I don't see it anymore. And there is a new message. What additional features from slides are planned to be ported into Insights? Well, some of them. I cannot tell you all of them at the moment, but for sure some are coming. Yeah, I cannot tell you now at the moment. I mean, it would be interesting to know which ones you, William, or others would like to see in Insights from GPR Slice, because that also shapes a little bit the priorities of our roadmap. Okay, I think people are saying just this thank you, goodbye kind of thing. We got enough, I guess. Oh, Augustine is asking for vector imaging. Yes, that's something that, yeah, definitely would be great to have in Insight soon.
So I think we also have more or less the results to the poll already. A great participation we had today, like over 160 participants, and
Thank you for coming.
Yeah, that's fantastic. And like more than 80% of them are actually very interested in knowing more about the presential, the live session masterclass. So. Please, if you didn't reply to the poll directly, send us a message and we'll send you the information. For all the ones that already said that they would be interested, we're going to share the details via email. And I don't know, I think this was a very wonderful and successful session. Dean, Alex, do you want to share anything before we leave?
Dean, you first.
Oh, no, I just want to thank everyone for participating and joining this webinar. And based on the response of having this many people, we're planning to make more. There are already 2 more webinars that have been recorded, and we'll be doing the same way live after the webinar to show any additional questions. But yeah, I think this is a good way to introduce the software and not make it too long. So keep it under an hour, and maybe people will be able to not sleep through it. We used to run workshops. We used to run workshops for 2 days, and by the middle of the second day, people are just saturated. So,
yeah, thank you guys. Same as Dean. I'm doing actually next week and in 2 weeks, two days sessions about also Insights. We'll mix it also with some hands-on GPR data, acquisition with different systems. So it will not be only post-processing. So 2 upcoming in Australia. Then Dean and I will be in Chongqing in China for a conference also showing GPR Slice. Then we think in October we might do some presential also in Spain. 2 more webinars are planned, and you'll hear from us soon. And then in November, Dean is going also for some classes in Kentucky, right, Dean, in the US.
I didn't know about it. You got the time.
Thanks, Alex.
That's the first time I heard about it.
No, it's not the first time, but it's the second time.
Okay.
Patrick is saying it's scary. Now on the chat. We already talked about it. So, anyways, we'll get in touch with you again.
Yeah, as Alex
So
shared.
a lot of new activities happening.
Sorry, as Alex just shared, we will have a series of webinar coming soon, and also some GPR masterclass, the physical one. Maybe some of them are near your city, so please watch out our website and take a look at that. We will update you, and after this session, you will receive the link of today's recording. Thank you, everyone, for your engagement and all the great questions.
Thank you.
Excellent.
Thank you, Alex.
Thank you
Thank
very
you,
much.
Dean. Yeah.
Thanks.
Thank you, everyone.
Thank you. See you next time. Bye.